Dear students, here we have problem 11 under the topic nonlinear partial differential equations. So if you see in the question, we could see that this equation has only p, q and z explicitly. So no other variables are present. So this is of the form capital F of z comma p comma q equal to 0. So for such equation, we have to make a substitution of q. So first let us mark the given equation as equation 1. And then in equation 1, we have to put q is equal to ap in equation 1. So when we substitute q equal to ap in equation 1, so at the place of q we have to replace it by ap. Here we have q square, and so it will become a square p square is equal to z squared p squared multiplied with 1 minus p square. So if you see, the p square on the right and the p square on the left will get cancelled, and we will be having a squared to be equal to z squared multiplied with 1 minus p square. So from this, 1 minus p squared will be equal to a squared divided by z square. We want p square, and so from this we can obtain p squared to be equal to, taking this to the right and a squared by z squared to the left, we have 1 minus a squared by z squared. And so p square will be equal to, taking LCM, we have z squared and z squared minus a square. So therefore the value of p is equal to plus or minus square root of z squared minus a squared divided by square root of z squared is z. So therefore we have obtained the value of p. Now we have to make a substitution of the value of p and the value of q in the equation dz is equal to p dx plus q dy. We know that q is equal to ap. So we shall replace q as ap in this. So ap dy. So we get dz to be equal to, p can be taken common, and so we will have dx plus a dy. And so this p can be brought to the left, and so we will be having z divided by p to be equal to dx plus a dy. Now we shall make a substitution, that is, at the place of p we shall substitute its value that we have found, which is plus or minus square root of z squared minus a squared divided by z. Here we have p in the denominator, and so we have to take the reciprocal of this and substitute here, that is z plus or minus z divided by square root of z squared minus a squared dz. So let us substitute p over here, and what we get is, so when we make the substitution of p at the place of p over here, what we get is, so plus or minus z divided by square root of z squared is minus a squared, and then dz is equal to dx plus a dy. Now integrating on both the sides, what we get is, now if you see on the left we have to use the substitution method. So let us put t is equal to z square minus a square. So what will be its differentiation dt? It will be 2z dz, and the differentiation of a square is 0. So from this we obtain dt divided by 2 to be equal to z dz. So let's make this substitution for t and z dz over here. So it will be plus or minus integral z dz can be written as dt by 2 divided by square root of z squared minus a squared can be written as square root of t, because z squared minus a squared is substituted as t. Okay, so that is equal to integral dx plus a multiplied with integral dy. So this will be plus or minus, this 1 by 2 can be taken out, integral t to the power. Now here in the denominator we have t to the power 1 by 2, and when it is taken to the numerator it can be written as t to the power negative 1 by 2 dt is equal to integral dx plus a integral dy. Now let us integrate. So this will be plus or minus 1 by 2 t to the power negative 1 by 2 plus 1 divided by negative 1 by 2 plus 1. We are using the formula integral x power n, which is x power n plus 1 divided by n plus 1. Here the value of n is negative 1 by 2. So negative 1 by 2 plus 1 divided by negative 1 by 2 plus 1 is equal to the integration of dx is x plus a multiplied with the integration of dy is y plus a constant of integration which can be taken as b. And so further on simplification we have plus or minus 1 by 2, and here t to the power negative 1 by 2 plus 1 is 1 by 2 divided by again negative 1 by 2 plus 1 is 1 by 2 is equal to x plus ay plus b. Now we can cancel this 1 by 2 and 1 by 2, and so we get plus or minus t to the power 1 by 2 can be written as square root of t is equal to x plus ay plus b. Now squaring on both the sides. If we square on both the sides, we will get rid of this plus or minus, and square root of t will be t only is equal to x plus ay plus b the whole square. But what is the value of t? Here we have taken t to be z squared minus a squared. So at the place of t, we have to replace it by z square minus a square is equal to x plus ay plus b the whole square. Taking this a square to the right, we get z square to be equal to a square plus x plus ay plus b the whole square. So this is the solution that we have obtained. So I hope you would have understood this problem. In our next video, we shall solve problem 12 under the same topic. Thank you.